All right, last one for this week. Again, not sure if how well you're going to be able to read this until I get them uploaded. But we're going to figure out how to find the force acting on either a wire or a charged particle. Now, the good news is you do them the same way. The only thing that changes is the equation, but the equation really isn't any different. So here's the problem I made. So what is the magnetic force on a 5 coulomb charge? I didn't write charge, but whatever. Moving away from you at 0.5 meters per second through a 3 Tesla field acting to the right. So the two equations that you have are F equals ILB and F equals QVB. So the ILB is for wires, the QVB is for individual charged particles. But they're really the same equation because they're both the magnetic field you're going through times the velocity and value of the charge. So here's the velocity and value of the charge. The reason why this one's different is because current is the speed, like how fast current is traveling, so it's the rate of flow of charge. So that's already got the over time in it. Current is charge over time. But it doesn't have the distance. Velocity is displacement, distance over time. We don't have that, so we add the length of the wire. That'll give us the distance component, and that'll give us the value between those things. So for this one, we have a charge. The value is 5 coulombs, so we're solving for the force. We're doing a charge, so it's QVB. The charge is 5 coulombs. I don't know why I'm struggling with my 5s today. V is the velocity, which is told to be 0.5 meters per second, and times the field, which is a value of 3. Okay, and when you multiply all those out and solve, you get a value of 7.5. And this is a holy buckets. And this is a force, so the answer is in newtons. But we're not done yet because we've got to have the direction. So my charge is going into the board. Okay. The field is acting to the right, so I need to point my middle finger in the direction of the field. And that leaves me with the force, which is my thumb, and my thumb is pointing down. So this value is 7.5 newtons down. Okay, there is going to be a quiz on Monday. It will be over just magnetic force acting on charges and wires, and finding the strength of the force acting around a wire, as well as concepts that go with that. It won't be particularly long. You have the review online. It's got a couple of problems for you to practice, as well as some concept questions to look over. I have not mentioned this yet. I was saving it as a special Friday thing. You will be able to use your notes, and you will be able to use any of the materials that you've done this week. Okay? You're going to have that stuff available all the time. I decided that I will allow that to be authorized aid for your quiz. You can't Google things. You can't ask other people to help you do it, or use other people's work. But you can use stuff that you do this week. So if you want to use, if you do the review, you can use that. So like I said, feel free to do that. That will help you. There should be time to do that on today's lesson. Today's lesson is not particularly long. It's solve these problems, and they're not particularly lengthy. So if you have some time to work on the review, you can use that on the test, quiz, whatever you want to call it, on Monday. I was hoping to do that today, but it just felt like squeezing in too much. So we'll do that on Monday, and then we'll get started on the next unit, which is going to be electromagnetic induction. We'll talk about it then. Have a great weekend. Bye!